Peace be on you. Before we start today's lesson, let me mention that I have this FM prep book on Amazon and it synchronizes with these YouTube lessons, but you know that the lessons are still under construction, but the book contains everything, contains all the 462 SOA sample questions and a lot of extra quiz and exam questions. And I would recommend that you always get the new book because you know that SOA keeps updating its material. It adds questions, it deletes questions, and sometimes it renumbers questions. And if you get one of the used books, it may be advertised as an updated one, but once you get the book, you will realize that it was actually an older version. And the only way to be guaranteed the latest version is to buy the new book that is sold by Amazon directly and not by the third-party sellers. Okay, so with that out of the way, let's get to today's lesson, which is about annuity due. Okay, an annuity due involves a sequence of payments with the first payment occurring at the beginning of the first period, as opposed to the immediate, where the first payment happens at the end of the first period. So suppose payments of 1 each happen at times 0, 1, 2, up to n minus 1. So we can count these are n payments. And the interest rate over each of these periods is I. Then the present value of this sequence at time 0 is denoted by an bracket and 2 double dots on the A. And it just equals 1 plus I times the corresponding present value of the annuity immediate. So this is always the case about anything due. If you know the formula for the immediate, the due can just be obtained by multiplying the immediate formula by 1 plus I. So if you want to write the more detailed formula, it's 1 plus I, and then times the formula that you already know for annuity immediate, 1 minus 1 plus I to the negative n over I. And if each payment is x instead of being 1, then you will just have an x multiplied up front, and the rest of 33.2 will be the same. And the accumulated value is again the fundamental rule that anytime you have a present value and you want its accumulated value after n periods, so you just multiply the present value with 1 plus I to the n. So if we want to write the more expanded equation for if each level payment is x, then the accumulated value for annuity due will be x times 1 plus I to the n minus 1 over I. So up to this part, you know it's the accumulated value of the immediate, and then you multiply it with 1 plus I, and it becomes the accumulated value of annuity due. Now, if each payment is 1, then a common notation for the accumulated value for annuity due is SN bracket and 2 double dots on the S. And then another useful relationship between annuity immediate and annuity due present values is AN double dot for the immediate equals 1 plus, AN double dot for the due, that's equals 1 plus AN minus 1 bracket, and this is for the immediate. So, and other very important thing is where all these values are sitting. So let's summarize everything for about annuity immediate and due. Present value of annuity immediate sits 1 period before the first payment. So you know the first payment happens at time 1, but the present value sits at time 0. And here by the present value, we mean the present value given by the formula of the present value that we know. And the present value of the annuity due sits at the time of the first payment, because here the first payment is happening at time 0, so that's where the present value sits. The cumulative value of annuity immediate sits at the time of the last payment. If you recall, in the annuity immediate, the last payment happens at time n, and that's where the uh, cumulative value is sitting if you use the cumulative value formula, which we know. And then for the annuity due, the accumulated value sits one period after the last payment, because the last payment is happening at n minus 1, and the accumulated value given by these formulas always sits at time n. So that would mean one period after the last payment. Okay.